Okay, now let's continue on with domain 3.3. Let's go over general data considerations. So we need to understand various aspects affecting data security throughout its life cycle to formulate comprehensive protection strategies. So data states. So we got to be aware of the different states our data can be in. They can be data at rest, which is like storage, data in transit, that's transiting the network like client to server, and then data in use is when data is being actively processed by our compute resources, okay? So depending on the state of data, we're going to apply protections differently, okay? Data at rest, we're going to do things like full disk encryption. Data at transit, we're going to implement things like TLS or IPsec. Data in use, we're going to have different memory protections like ASLR. I think it's address state layout randomization. We have NX and XN bits that can be configured to help us protect our data in memory. Data sovereignty. So one thing we have to be aware of, guys, that if we're managing or taking user input, customer input in different regions, we have to be aware of the local compliance rules and regulations and the legal requirements. So if we're managing or taking in customers from EU, guess what? We better get used to the GDPR. If our company just want a contract to manage government systems, guess what? We're going to have to be aware of NIST systems. If we deploy our own point of sale machines and we don't use a data processor like, I don't know, WooCommerce or Shopify to do our e-commerce, guess what? We better get pretty familiar with PCI DSS. Geolocation. So we got to understand the geolocation of the different applicable laws affecting the compliance and legal risk depending on our location. Very similar to data sovereignty, right? Now we just got to be aware of, okay, not only the legal and law implications, but also the strategy. If our customers are on the East Coast, probably not very smart of me to deploy applications in a cloud region on the West Coast. Methods to secure data. So now we're going to go the different ways we can secure our user data, customer data, okay? So we got to think about geographic restrictions again, just kind of repeating ourselves here, saying we totally depends on the level of security that we need to comply with depending on our geographic region. In the US, we don't have data privacy laws. So maybe it's not actually by law, we'll go to jail if we don't do proper restrictions. We may have to pay a fine or a fee. Same with the GDPR as well. If we don't protect the data privacy of users in the GDPR, we get fined a lot of money, right? Some companies, they just think of this as cost of business. All right, methods to secure data. Encryption, guys. We always want to use our different various cryptographic and encryption controls to protect our data. So that's using symmetric, asymmetric cryptography, doing full disk encryption for our data at rest, doing TLS for our data in transit, hashing. So if we want to secure our data and make sure that we have integrity and authenticity, we can do hashing. We can hash our databases or our password databases. Data masking. So data masking involves obscuring specific data within a database to prevent unauthorized access, okay? So this is just masking the data, not changing it plain text to ciphertext, just changing some things and masking the environment the data sits in, okay? Tokenization. So tokenization involves replacing sensitive data elements with non-sensitive equivalents. We do this with our Apple Pay and our Google Play, where we have a token database that correlates to a user's checking, debit, or checking, savings, or credit card account. And when we use Apple Pay or Google Play, we exchange, instead of the credit card information across the wire, just a token, a unique identifier that matches and correlates to our financial institutions. So if there's a data breach of that tokenization database, it won't do nothing, right? Because a token can be unique through every transaction, so that protects the original data, the credit card information. Obfuscation. So obfuscation involves deliberately making data or code ambiguous or confusing to prevent unauthorized understanding or modification. So obfuscation is used to protect sensitive data in code, making it difficult to understand and making it difficult for unauthorized users to reverse engineer or decipher. So some techniques, right? So we can do data scrambling, which obscures data patterns, but there are limitations, right? While obfuscation adds a layer of security, it is not foolproof and can be decoded or reversed by APTs, essentially, or determined adversaries. Segmentation. So we talked about this in previous sections as well. If we want to protect data locally, if we want to separate and apply different policies depending on our security objectives, we can create subnets, virtual LANs. We can do east to west micro segmentation, okay? We can segment and isolate certain data depending on how well we want it to protect it. Permission restrictions. So this is going over stuff like least privilege, guys, making sure that we have the proper restrictions on our data, making sure that only people that have this specific role or the need to know can get access to our data. All right, let's go ahead and do our check on learning. All right, let's bring this up. Okay, so question 1. What is the primary purpose of tokenization in data security? That's going to be B, to replace sensitive data with non-sensitive equivalents. Question 2, how do geographic restrictions help in securing data? That's also going to be B, by limiting where data can be stored and accessed geographically. Question 3, which of the following is not the most effective method for securing data at rest? Or sorry, which is the most effective method for securing data at rest? So not going to be A, right? That's data in transit. Strong passwords has nothing to do with protecting data at rest. Like obviously if we're using a password to access something, like okay, it's protecting it. Regular software updates is something that should happen in enterprise, but it's not going to be our answer here. That's going to be B, full disk encryption. So that's things like BitLocker, right, guys? And what our iPhones do automatically. Question 4, what is the major difference between encryption and hashing in data security? So this is very like computer science question. I'm probably going to edit this, but yeah, encryption is reversible while hashing is not. That is very true, but hashing is vulnerable to collisions, right? And to reverse encryption, that means you need the key or to crack the algorithm entirely. So while that is true, I'm going to edit that question for sure. So question 5, what is a primary concern when storing data in a foreign country's data center? So we're not going to, we got to worry about our different techniques here, right? Masking and tokenization. Definitely geographic restrictions as well, but geographic restrictions also play into the availability of data, as in like, okay, we got to worry about latency and things like that. The more correct answer here is going to be data sovereignty, okay? This refers to the concept that data is subject to the laws and governance structures of the country in which it is located. Question 6, which protocol is primarily used to secure data in transit over the internet? That's going to be TLS, right, guys? SSH can as well. SSH definitely can, but that's not the primary protocol over the internet, okay? That's going to be TLS.